placed inside a tiny metal vacuum called an oscillator, each one the size of an ant. The quartz can then be linked to a circuit board, which is programmed to count the 32,000 pulses, then return to 0. Which means the constant vibrations made by the quartz are translated into electronic pulses, each one a second long. And that's how a rock becomes a clock. At Seiko Epson Shiojiri factory in Japan, the oscillator is just one of 250 tiny parts that they have to fit inside each of the watches they make. And the workers who assemble these parts have to pass through a special dust-free wind tunnel. One single speck of dust could ruin their day. The assembly process involves both humans and machines. And the same interaction of man and machine is how Seiko Epson have overcome one of the greatest challenges in watchmaking: how to create a watch that generates its own electricity. What they've done is to use the motion of the body to power a kinetic watch. The kinetic watch captures the energy from the natural movements of the wearer's arm, amplifies it, stores it, and uses it to power the timekeeping mechanism. Seiko Epson has essentially reduced a power plant to the size of a thumbnail. Unlike other watches, the designers of the kinetic watch take positive advantage of the fact that it's worn on the wrist.
The kinetic watch is unique because it only needs arm movement for power.
So how have they done it? An oscillating wheel turns each time the arm moves. This movement is increased 100 times through 3 cogs and eventually reaches one of the smallest components in the watch, the rotor. This is the heart of the kinetic watch. It's just 1/4 millimeter in diameter. To produce the 1 volt of energy needed to power all the parts inside the mechanism, the rotor spins at a speed 5 times faster than a Formula 1 racing car engine. And that's how the simple movement of the arm creates energy. But what's clever about the kinetic watch is that it also saves energy, especially the part that needs more power than any other, the hands. They only need power when they move and not between the ticks. In theory, this watch could be worn by one person from the moment he or she is born and never stop. It's an awesome thought. But for this to happen, the watch needs to be sealed for life and never opened or exposed to the atmosphere. To make sure it stays sealed, it goes through a series of rigorous tests. In a high-pressure cylinder, the watches have to withstand deep-sea depths. Then, they're submerged in water to check for leaks. If water is present, drying the watch on a hot plate will reveal condensation on the glass. These watches have passed the test. Now the kinetic watch can last a lifetime and join the rest of the world's watches to mark and maintain the daily rhythms of the human race. Five ordinary objects, 5 extraordinary stories. Coming up, it's a novel form of power supply and its biggest enemy could sit on your fingertip. The secrets behind wind turbines, next on How Do They Do It? They stand like giant sentinels against the sky. The only apparent movement, massive blades silently spinning. Look around, and there are dozens of them. Look again, and there are hundreds. Look again, and the effect is hypnotic. The spinning blades lazily drifting in and out of synchronized movement. But how does a wind turbine work? The first ingredient, of course, is wind, and plenty of it. This is the Tehachapi Valley in Southern California. The geography of this valley makes it one of America's windiest spots. Tehachapi lies at the edge of the Mojave Desert. As hot air rises from the baking ground, cooler air is drawn from the Pacific coast, some 200 kilometers away, and funneled up the valley. Weathermen call it convection, and it's why Tehachapi is surrounded by more than 5,000 wind turbines. Turbine engineer Michael Burns works for Oak Ridge Energy Systems, one of the dozen or so wind farms that operate in Tehachapi. It's Burns's job to keep the turbines turning. And the biggest challenge he faces is one you might not expect: bugs.
The bugs deposit on the blade, on the leading edge, and when the air is supposed to follow the contour of the blade, instead of following it and staying attached, it's like it hits a speed bump, so it comes around and goes like this away from the blade, which causes it to lose lift, which is kilowatts. You could turn a 750 kilowatt turbine into a 400 kilowatt turbine just from bugs on the blades.
Bugs can seriously hamper electricity production. In the Oak Ridge Energy Systems Control Center, staff have come up with a neat solution. At the press of a button, a computer triggers this. It's a kind of giant car wash, and it's designed to keep the blades clean and bug-free. Clean of bugs, the blades can rotate up to 50 times a minute. Their job? To convert the forward movement of the wind into a circular motion, and then translate that motion to the business end of the turbine, the generator. The generator is housed in a compartment called a nacelle. The only problem? It's around 60 meters off the ground. And the only way to get to it is straight up. It may seem a daunting prospect, but to Burns, it's all part of the job. At the top, the space inside the nacelle is cramped, but the views across the Tehachapi Valley are spectacular. At last, the business end of the turbine is revealed.
Okay. Main shaft, gearbox, the generator. So that lift is converted into horsepower, which is then converted into energy.
The raw current runs through these massive cables all the way down to ground level. At the tower's base, the cables link to a transformer. Here's where the second bit of magic occurs. The transformer bounces the electricity between two magnets of different strengths. The result is a step up in the current from 25,000 to an awesome 450,000 volts.
When the wind is up high enough and all the turbines are producing what they're supposed to, this part by itself could supply 34,000 volts.
To provide electricity for even a small windy town like Tehachapi takes an awful lot of windmills. But wind turbine technology is still in its infancy, and engineers like Michael Burns are determined to make it work. The world spins through another day, another night. Industry never sleeps. Somewhere, somehow, someone is at work, designing, producing, distributing. Since this program began worldwide, we have mined over 25,000 tons of salt. 143,000 pairs of running shoes have hit the world's streets. And with a fair gust, a giant windmill has managed to power 11 million 100-watt light bulbs. The rock on your wrist has made your watch tick around 3,000 seconds. And another 100 tons of steel have been forged into a chunk of giant ship. Even the most ordinary objects often have an extraordinary story to tell. We only have to watch and listen.